if P and Q are prime numbers, if P and Q are prime numbers, how many divisors does the product P to the power 3, Q to the power 6 have? How many divisors does this have? So to explain this, what I'm going to show you now is I'm going to assume that P is a prime number. So if P is a prime number, is a prime number, so what I'm going to show you is I'm going to derive a formula for finding the number of divisors of numbers of the form P to the power m, so such that the P you have here, let's say the P you have here is a prime number, and then the m you have here is an integer, say any integer. So you recall we said an integer is just a whole number. So anytime you have a number of this form, an example is say you have 3 to the power 5. 3 is a prime number, 5 is an integer. Another one is maybe you have 2 to the power say 7. This is a prime, this is this is an integer. So these are the examples of numbers I want to derive a formula for. So anyway, let's go ahead. You get your understanding very soon. Don't worry. Now the first one is, assuming you are given 3 to the power 1. Now this is 3. 3 is the same thing as, that is 3 is the same thing as 3 to the power 1. Let's call this 1. Now, if you're told to find the number of divisors of 3, the number of divisors of 3 are just 1 and 3. That's all, right? So the divisors, let me just write this here. So you have the divisors. They are, you have 1, 2. So you have 2 of them. You have 2. Let's look at another number. As when you have 9, let's say 9. 9 is the same thing as 3. So it's the same thing as 3 to the power 2, right? So the number of divisors of 9, if you want to find the prime factors, all the prime factors of 9, including 1, is going to be 1, 3, and 9. That's all. So for this number, how many divisors do we have? We have 1, 2, 3. So we have 3 divisors. Let's see another one. Let's say you have 27. 27 is the same thing as 3 to the power 3, 3 to the power 3, and then this is 27. So if you want to list the whole number of prime factors of 27, the numbers are 1, 3, 9, and 27. So how many divisors do we have? 1, 2, 3, 4. So we have 4 of them. Now what I want you to observe is that there is a relationship between the power you have here and then the number of divisors you have here. So you note the kind of numbers we are considering are the numbers of such that the base is a prime number. You can see 3 is a prime number, and then the powers are integers. Those are the numbers we are considering. So what I want to explain now is, what you'd observe is that the power you have here and then the number of divisors you have here, there is a relationship. Now what is the relationship? For 3 to the power 1, the number of divisors is just 1 plus 1. That is, just add 1 to this, you obtain 2. Also here, the number of divisors, the power you have here is 2, while the number of divisors is 3. That is, 3 is obtained by adding 1 to 2. That is, this is just 2 plus 1, you obtain 3. So similarly, the power you have here is 3, and then how did we get the number of divisors? By adding 1 to the power, that is 3 plus 1, you obtain 4. So let's see, assuming you are told to find the number of divisors of the number, say 2 to the power, let's say 5 to the power, let's say 2, 5 to the power 2. So based on the formula we have here, and then since this 5 to the power 2 is of this form, why is it of this form? The base is a prime number and then the power is an integer. So if you're told to find the number of divisors of this number here, which is 5 to the power 2, which is 25, so we said you don't have to start writing down all this. All you just need is just use the routine we've just shown here. It's just going to be 2 plus 1, which is 2 plus 1, which is going to be 3. And then we can confirm the prime factors of 25. They are just what? They are 1, 5, and 25. That's all. So that's a confirmation. So that's to tell you now that anytime you have a prime number, so if you have a prime number, say p, a prime number p, so this is p, and then maybe it has a power here m, and then you're told to find the number of divisors of p to the power m. Since p is a prime number, so the number of divisors is just going to be m plus 1. So what I'm going to do now is I'm going to let a formula to, I'm going to use let's say sigma represents a function. Let this be a function that gives the number of divisors, so sigma is going to be a function that gives the number of divisors. So what do I mean here? So for example, for 3 to the power 1, if you're told to find the number of divisors, so using this formula here, we'll just say sigma of 3 to the power 1 is just going to be 1 plus 1, which is 2, right? So sigma of 3 to the power 2, sigma of 3 to the power 2 is just going to be 2 plus 1, right? That's 2 plus 1, which is 3. So sigma of 3 to the power 3, so sigma of 3 to the power 3 is just going to be 3 plus 1, 3 plus 1, which is 4, sorry. So what I'm just trying to do is I'm trying to make a short form instead of saying number of divisors. So I'm using a formula now. So that is to say, if you have sigma of p, or say 3 to the power n, equals, so whenever you hear the word sigma, I'm just trying to say the number of divisors of this form, of numbers of this form, is just going to be n plus 1, right? Okay, now we understand this. So this is a special case. We call this case 1. Let's now go to another special case. But before I write the special case, let me just write a general formula for this sigma. So that's to say, anytime you're told to find the number of divisors of any number of the form p to the power n, so according to what we've been showing here, we said the number is just going to be n plus 1. So now we know what this means. So sigma here just simply says the number of divisors of p to the power n equals n plus 1. So I'm going to consider another case, which is case 2. So in the first case, you observe that you only have just a single number in the bracket. So what if you have two different prime numbers of this form? How do you handle that? Well, what I'm saying is, if you have if you're told to find sigma of, that is the number of divisors of p to the power, say p to the power n, times a different number, let's say q to the power, say m, p to the power n and then q to the power m. Maybe you want to find the number of divisors of two prime numbers that multiply themselves. Well, because this is I'm just giving you tips that you use in your exam, but this can be proved. But then what I want you to just know is the function that you have here, that is sigma, is a multiplicative function. It is a multiplicative function. What do I mean by a multiplicative function? For example, if you have sigma of 2 times 3. Now, since sigma is a multiplicative function, it implies that this is just going to give you is the same thing as sigma of 2 times sigma of 3. So when you say something is a multiplicative function, it implies that it can be applied to each of them and then it affects nothing. That is, you can apply them and then your product sign still, it preserves the multiplication sign anyway, in short. So if you have sigma of a dot b, so this is just going to give you sigma of a dot sigma of b. So this is just multiplicative. So that's to tell you that if you're told to find, let me now come back here. So now note, my aim is, this is something that might look new to you, that is sigma is a multiplicative function. It can be proved, but we are not going to prove this in this video. So but just know that sigma is a multiplicative function, that it can be applied in this way. You can verify that by trying some different numbers. So since we know that sigma is a multiplicative function, if you're told to find sigma, that is the number of divisors of numbers of the form p to the power n, say p to the power n times q to the power m. So since we said that sigma is a multiplicative function, it implies that it preserves the multiplicative sign. So this is just going to give us sigma of, you have p to the power n times q to the power n. So that's sigma of q, that's q to the power m. So this is what you have. So we can just use different colors so that we'll see what's happening here. So sigma works on this first, and then sigma works on this first, as if you're expanding. That's how it looks like you're expanding, as if you are doing 2 into a plus something. So you can expand that normally. So and then you observe that, you know, sigma here, the sigma that we have here, it represents the number of divisors of a prime number that is written in this form. Sorry, a number that is written in this form here. So and then we said the formula is just add one to this. This is what you obtain. So since you have sigma of p to the power n, this is just going to give you it's just going to give you, let's not confuse this. It's going to give you, so sigma of p to the power n is going to be n plus 1. This will be n plus 1 times, so sigma of q to the power m is going to be n plus 1. Now shall you see how this is obtained? All right, let's now go to the question. The question says, how many divisors does the product p to the power 3 q to the power 6 have? And we are told that p and q are prime numbers. So what we have here is p to the power 3, p to the power 3, and then we have q to the power 6. So we are told to find how many divisors does the product have. So the number of divisors, we said, is just going to be sigma of, this is just sigma, is going to be sigma of this, right? The number of divisors of this is p to the power 3 times q to the power 6. So what we said is that this sigma here is like, it's a multiplicative function. That is, you can expand this like you're doing normal expansion. Like what I mean is, if you have 2 times a plus b, 2 times a plus b, so this is just going to be 2 times a plus 2 times b. So you can see, so what you have here is sigma of this plus this. So this is just going to be sigma of, so this is p to the power 3 times sigma of q to the power 6, yeah. And then we've obtained a formula below that sigma only acts on the power you have here. So this is going to be 3 plus 1 times sigma of q to the power 6, which we said is 6 plus 1. So the formula I'm using is the formula we obtained here. So sigma of p to the power n is n plus 1. So and then 3 plus 1, this is going to give you 4 times 6 plus 1 is going to give you 7. And then 4 times 7, that is 28. So our answer is 20. Answer is 28. So this is the solution. So again, you can watch this video 1, 2, or 3 times so that you get a very good grasp of the idea that is being explained in the video. Thanks for watching.